Next up for derivatives is the product rule. So in other words, the derivative of two polynomials being multiplied by each other. So the derivative of f of x times g of x is going to be f of x times g prime of x, in other words, the f of x times the derivative of g of x, plus f prime of x times g of x. And make that a little more obvious that that's a prime, not just a continuation of the letter f. So it's the first function times the derivative of the second plus the derivative of the first times the function or the second function. So looking at f of x here, if we kind of like labeling them, I don't know, you can choose whatever labels you want. Say that's j of x, and I'm going to call this one k of x. I would encourage you to take j prime and k prime separately. So j of x, taking the derivative of this first group here. In fact, let me color code this. Maybe that'll help a little bit too. So I'm going to call k of x in blue. But the derivative of j of x would be 10x, and that's it. Now the derivative of k of x will be k prime of x would be, 2x minus 4. So taking the derivative of the whole function f prime of x, I'll do that in green just to make sure I'm not conflicting colors. So we got f prime of x. We're going to take the derivative of, we're going to take f of x, which was, the first function I should say, which was the 5x squared plus 8, and multiply it by the derivative of the second one, which was 2x minus 4. Then for the second group, we're going to take the derivative of the first one, so it's going to be just 10x, and multiply that by the whole original function, or the original k of x, the original second group, which was x squared minus 4x minus 6. I just noticed I kind of failed on my color coding for a second, so let me change something here. I'm just going to change the color of that first group there. And for now, we're going to leave it like this. We're not going to go through and distribute. For the second one, you can label them whatever you want. Just for kicks, we're going to go call this one d of x, and we'll call the other one b of x, db. Those are some good initials. So separately, derivative for d of x, it'd be 3x squared plus 7. The derivative for b of x is just 1. So when we're doing f prime of x, it's going to be the first original function, so it's going to be the x to the third plus 7x times the derivative of the second. Well, in this case, that's just 1, which is kind of nice. Oop, color coding, sorry. Keep having to switch colors. Plus the derivative of the first one, so 3x squared plus 7 times the second function, which originally was x plus 3. Now again, we can clean this up just a little bit. You can always go through and distribute if you want. I'm just going to distribute one small part, the 1 times that x to the third plus 7x. That's just going to be x to the third plus 7x. And then the other group is still going to be plus 3x squared plus 7x, plus 7 times x plus 3. Now, number 3 initially doesn't look like it's a product, but it is, because x squared minus 1 squared really means x squared minus 1 times x squared minus 1. So if we're doing the derivative of the first one, so I don't know, I'll call these g and I don't know, r. I'm just making up letters now. So the derivative, I'm going to stop color coding just so I don't have to keep flipping inks here. We got g prime of x would just be 2x, and r prime of x would also be just 2x. So when we're doing h prime of x would be the first function, which is x squared minus 1, times the derivative of the second, so that'd be 2x, plus the derivative of the first function, 2x, times times the second function, which is x squared minus 1. There's a lot of repeats here. It's this whole thing plus this whole thing times itself. In other words, if you want to simplify it a little bit, you could do it as two of those groups, because it's, again, those two groups are the exact same thing, x squared minus 1 times 2x. If you really want to clean that up just a little bit more, you can make it 2 times 2x would give you 4x times x squared minus 1. Again, you can distribute, you can distribute, you can distribute as much as you want, but for simplicity's sake, we can call it good there. Now, we're going to get into some more interesting ones, combining some properties we looked at in the previous sections. So, on number 4, f of x equals the square root of x, times the sine of x. Again, this one, let's just call it g and h. I'm going to keep that simple. So, the derivative of g of x, well, maybe we should rewrite this. I'm going to rewrite the square root of x as x to the 1/2 power times the sine of x. So the derivative of g of x, in other words, the derivative of x to the 1/2 power, would be 1/2 x to the negative 1/2. The derivative of h of x, the derivative of sine of x, is cosine of x. That's what we learned in the previous section. Now, going with the derivative of f prime of x, it's going to be the derivative of the, it's going to be the first function, the square root of x, times the derivative of the second function, so it's times cosine of x, plus the derivative of the first function, which was, well, I guess I didn't clean that one up a little bit. That'd be 1 over 2 times the square root of x. So it'd be 1 over 2 times the square root of x times the original second function, sine of x. And that would be our derivative there. Couple more here, wrapping these up. Again, identifying separate pieces here. So like this is going to be one piece, this is going to be another. Let's see, we call this one g, so let's do h of t and, no, I'll just go f of t. Oops, sorry, that's f of x. So h prime, the derivative of 2t to the 5th would be 10t to the 4th. And then for f prime of t, the second piece, the derivative of cosine is negative sine of t. So g prime of t is the first function, that 2t to the 5th, times the derivative of the second, so times negative sine of t, plus the derivative of the first function, 10t to the 4th, times the second function, cosine of t. We can clean this up just a little bit. We got g of x equals this 2t to the 5th times negative sine of t. We're going to make it negative 2t to the 5th sine of t. So just a little bit of cleaning up, plus 10t to the 4th times the cosine of t. If it helps you to put those in parentheses, not a bad thing. Number 6, finally. This one, we've got two separate pieces here. One I would say is 4x, the other one I would say is e to the x. So let's just call them, I don't know, c of x and b of x. I don't know why I chose in that order. So the c prime of x of 4x is just 4. D prime, or sorry, I'm looking at my notes, I had d prime on there. B of x, d prime would be, well, e to the x. That was from the exponential property we learned last section. So f prime of x, it's going to be the first function, 4x, times the derivative of the second, so e to the x, plus the derivative of the first, 4, times the second function, e to the x. And we can leave it just like that. If it helps you to kind of like put parentheses around things to kind of help you remember where they came from, like 4x was its own function, e to the x was a derivative, 4 was a derivative, e to the x is also, or was another function, that works for me.